Hello and welcome to today's edition of Capgemini Build Tech Talks. My name is Robin and I'll be your host for today. Today's topic is data cleaning, techniques for identifying and filling in missing data. Our speakers today are two colleagues of mine from Capgemini Blue Harvest, Francis Dreyer and Andre Marquez. And together they have a combined experience of over 15 years. Today's session will consist of two parts. The first part will be more of a theoretical look of missing data, how to identify and classify it. And the second part will be more of a practical demonstration about how to use these techniques, right? But first, I have a question for you guys. So why did you choose today's topic?
Well, I had a project a while ago, and then there was missing data in there. But then the first thing people were thinking of is just fill the gaps with means and then start looking at the model, fine-tuning the model, and get the model as good as possible. Then I was thinking, shouldn't we spend more time looking at the beginning part? There's missing data. Should you really just fill it with a mean? What's the implications? What are other options? And is that really the best option? And Andre also had a similar experience.
Yeah, my experience was working with a data science team. So they were working hard on tuning the model when actually the data input that we were doing had lots of gaps, lots of inconsistencies. So pretty much we were not looking very much at this end. So that's why we thought that would be very important to bring to our community.
All right, nice. So if you have any questions about today's topic, you can ask them in the chat, and at the end of the session, I will read them out. But before we get into that, we have an exciting giveaway for you. If you want to be in with a chance to win one of these Capgemini Build hoodies, then you can. All you have to do is pay close attention to the talk and answer a question at the end. There'll be more about that later. So with that, over to you guys. Good luck and enjoy it.
Thanks so much.
Thank you.
Yeah, so like Robin was saying, we'll be looking at data cleaning, so especially looking at the techniques for identifying and filling the missing values. We'll be looking at three parts. Firstly, look at the why. The why questions: why should you care? Why should we actually fill the gaps? Next, we'll be looking at identifying. So identifying that there is missing data and the reason why it's missing. And lastly, we'll be looking at how to fill the gaps. So we'll be looking at non-time series data as well as time series data. So we'll be filling in this roadmap as we go. So firstly, on the left-hand side, we'll be looking at missing data, first seeing is there missing data or not, and fill it as we go. And at the bottom, you'll see the three categories. So the why questions, identify, and fill the gaps. So hopefully at the end, you'll have a nice full picture of what you should do.
Yeah, right. So when we go for the why part, we have many whys that we could consider and pay attention and spend some time on looking at the missing values in our data sets, depending on the roles that we also play in the team. So for example, if you are a developer and you want to make sure that your code will run fine and smooth, so probably you need to have all the values that you are considering on your code to run that fine. So, and if you are a data analyst, you want to have insights and also drive your decisions with data that you actually rely on. And if you are a data scientist, even more important that you build your models considering data that is filled and has values that will be considered when you have the results for your model. So having good sites, even though you are not even tuning that much your model.
Exactly.
Yeah.
So first question is identifying the reasons for missing data. So if you have missing data, that's what we'll be looking at. If you don't have missing data, nothing for you to do at the moment, but please continue listening. You'll probably have some missing data in the future, and then you will know what to do. So the scenario for this talk, we thought we'd take a light approach, is cats.
Yeah, that was a decision that we took, but cats are great. Yeah. Let's go for some categories that we have on missing data. So we have three main categories. So missing complete at random, missing at random, and also missing not at random. So we'll go through each of them. So for missing completely at random, we'll go for data that is missing on our data sets that due to some external factor or is not related to any value in the observation. So let's say, for example, we are getting data from many observations from cats, and somehow some data there is some inputs not coming to because of like the sensor is not on, or the scales battery is not working that properly, but it's not related to the data set at all.
Exactly. So missing at random, that's now where the column that actually has missing data is related to some column that has complete values. So for example, at the bottom, you'll see there's a column called sick. So if your cat is sick, it means that cat could not attend the appointment, and that means the weight value would be missing. So in this case, it's a column in your data set. So it's due to something in your data set that's causing the missingness. So if you think back at missing completely at random, that's an external factor. That was the battery being low, or like you were saying, a signal not working. So that's something external. Missing at random, something internal in your data set that you can link the two columns and say that the missing column is dependent on a different column that doesn't have missing values.
Right? So that goes to our third category, that is missing not at random, is when our observations has a reason for not being filled. So let's say some cat's tutor doesn't want to fill if cats are overweighted, or maybe we have some form that we don't want to answer our salary range or our age. So depending on the data set that we have, that must have some apparent reason. So that's pretty complicated actually to realize when we don't have a domain knowledge about the data set.
Exactly. So missing not at random, like you were saying, just to emphasize, is the most complicated one to figure out and also to fill. One option is to go back to the owners and ask them to fill in the weight, but when's that actually really possible to go back? So this one is more complicated to fill and to identify as well. So now we've identified 3 reasons: missing completely at random, missing at random, and missing not at random. So next steps is to visualize the data. So when we were doing the analysis, I found this really cool article, Jan Kagel, for visualizing the data. I went to Andre really, really excited and showing this is awesome. So you can actually see what's happening in your data. So this is super useful just to be able to go to your data set, display it, and see in a graph, there you go, what's happening in your data.
In just a few lines of code, so that's not actually programming at all. So we just put some libraries that they're quite common in Python. There are lots of ways of doing that. So this visualization makes that very clear on if we are having some gaps in our data set.
So here you can see very clearly the weight column and the age column has quite a few missing values. Some of them, like hair type, you can see there's a total of 10,864 records, but the hair type has a few missing. So there you can clearly see which ones is missing a lot and some are just missing a few. And it's nice to see that it has missing data, but you also want to see maybe the positions, which is what you can see in the next slide. So here you can see white lines is the records that have missing data and black is where it's filled. So here you can try to see maybe it's correlated or not correlated. So this is just a good way to see per record where it's missing.
Yeah. If we do the same thing but ordering these columns that we have, so we have we have this clear vision of what we have, if we have some correlations, and where are they missing.
Exactly. So sorting on this weight column, you can see it doesn't look like it's dependent or correlated with the age column. So it could be missing completely at random. It doesn't seem like they're correlated. And there you can also more clearly see that hair type looks like about 3 records missing in the data set. So it also helps to just show per record, there you can more clearly see what's happening. Then missing at random. So if you remember the definition, it says that the missing column has something to do with a non-missing column. So here it looks like age and weight are missing at the same spot. So they could be, it looks like they're perfectly correlated, but then you have to dig further. It might be dependent on some other column in there. So if you see something like this, you'll probably need to dig a bit further to see what's happening. And you can also sort and you see it's, like I said, perfectly matching.
Perfect matching, yeah.
Yeah, then also the last one is missing not at random. This is, like Andre was saying, very difficult to identify and also to visualize. So if you look at that, you need more domain knowledge and you need to dig further into that. So let's say you've got these 4 columns, and once again, it's for cats. You've got the age, the number of gray hairs, and then the gender and weight. And you can see only number of gray hairs, there's a few missing values. So digging further into that, we're going to look at only those missing records and split them and see male versus female or just the unique values in there, you see only male values are missing. So that already seems a bit suspicious if only male cats did not fill in something about gray hairs. And it's like, interesting, dig further. You see the average age, just where the gray hair has missing values, that's 16.5. But the average for all males is 10, which means where it's missing, the age is higher. So it could be that only older cats did not fill in the number of gray hairs, which sounds once again a bit fishy.
That's the part about the domain knowledge that helps us to understand if we have some missing data regarding to some specific value or some specific observation that we got in our data set.
Yeah, like you were saying, then domain knowledge, looking further, you see that the male cats only have a range 0 to 13 for gray hairs, number of gray hairs. Females have a larger range. So the male cats on purpose did not fill in the number of gray hairs as they get older, cause probably some issues. And just lastly, so another method, you don't necessarily have to visualize. You can also go the numeric way. I'm not going to go into too much detail, but you can use dummy variables. So for each column, if it's missing values, you put a 1. If it's not missing, you put a 0. Then you do a t-test and a chi-square test, and you can see if some of these columns are dependent on each other or not. This can only be used to identify missing at random or missing completely at random. For missing not at random, you need a bit more domain knowledge and dig in further. But if you run this and you see that one column is not related to another column, it's probably missing completely at random.
Yeah, and also all these things are, we have very cool libraries open and available to do that. So that might sound
way easier.
way easier. So all right, so we already identified if we have missing data or not. We already saw what kinds of missing data that we have and some reasons why. So let's go into filling these gaps the same way as this cat is filling the gap of this box.
So we've got two main reasons for filling the missing data, either deletion or imputation. And digging a bit further into deletion, you get column-wise deletion, row or list-wise deletion, and pair-wise deletion. And then looking at imputation, this is now specifically just for non-time series. Andre will look at the time series later. So you'll fill with a constant value, fill with mean, median, or mode. And then you can also use some predictive or statistical models. We'll not be focusing on them tonight. We'll just be focusing on the more simple ones for now, just to get the point across of how important it is and what just the simple methods, what they could do for you to help.
Yeah. One way of inputting data is inserting mean, median, or mode. So let's go very briefly about each of these techniques, each of these calculations. So for example, if we have an array of data that we have some values, weight of cats, for example, that all these values. So for example, mean, that's pretty much summing all the values and dividing by the number of values. So for example, for this array, we've got 9.3. Median would be sorting all the array and taking the median part of this array, and mode, the most frequent value in the array. So that's how we're going to get all these three values for our inputs later on.
Yeah, so column-wise deletion, that is if you for some reason want to delete the column, usually the reason would be that too many values are missing in that column. For this example, only 2 values of the 9 is filled. It could be a good solution to maybe just delete that column. So all you do is remove the column and you're left with just 2 columns after that.
Yeah. And also we have row deletion and list-wise deletion. So we would go from rows that we see that will not be useful for us in our data set. So that's pretty much deleting the rows rather than columns.
Yeah. Also, just to add, the row-wise, it's if any of the records or any of the columns in that row has any missing data, you just remove that. But that is not always the best option. You lose a lot of data by removing that. It could be a good option if you've got a really big data set and a small fraction is missing, and it is missing completely at random, so you won't lose data. That could be possible.
Yeah, that's right. So depending on the situation, and also the discussion that we want to bring tonight is also how manage if we want to delete or input. and do in the best way possible, considering that the data and the data set got to bring all the value that we want from it.
Exactly,
Yeah.
and linking it back to the missing not at random cat example, imagine if you removed all the missing data, you'll be removing all the older male cats. That's a whole big portion of your data your cat population that you're just removing. So it's not always the best option. You need to know what's going on in your data.
Sure.
And pairwise deletion, that's a bit more tricky to understand, but all you do is you remove all the missing values, but just for calculations. So if you need to maybe calculate the average weight, you just take the values that are available and divide it by the number of values that are available. So in this case, 6 values divided by number 6, and then you get your average weight.
All right. So one example of filling with constant value would be fill some rows or columns that we see some gaps, and then filling with constant value.
Yeah.
But again, we will discuss a little later on, so how to manage that and which option is the best on filling those.
Exactly. So you can get the mean, like we've explained, Andre explained nicely what the mean is, just all your values divided by how many there are, fill the gaps with the mean, and then you've got your nice filled data set.
All right, pretty much with median. So we've got our calculation for median. So we ordered all the values that we have at the array. And then once we got this number, we can fill in the gaps with the median.
And then lastly, mode. Once again, like Andre is saying, it all works the same. You count how many times does a certain value occur. In this case, you get 23 occurring 3 times. That's the value that occurs the most. And fill that in, and you get 23 in all of the gaps. So that's the end of filling the gaps for non-time series. Just to emphasize again, we're looking at the simple methods for this talk. You can use a statistical method as well, which is usually what you need for missing at random and missing not at random. But we'll be looking at the simple ones just to emphasize, once again, that it can make a difference. So we've done the mean, median, and mode. Now we want to know, when do you choose it? So it's lovely that people say you can use mean, median, or mode, but when do you actually use the different ones? You need to know. So firstly, like I said, determine missing at random, missing not at random, or missing completely at random. Just to reiterate what I just said, missing not at random and missing at random, usually not your best idea to just use a mean, median, or mode, because missing not at random, like the example with cats, if you just use the mean, you're excluding some part of the data set, so the mean will not usually give you the most accurate data or accurate answer. Missing at random, the missingness is related to another column in the data set, so you'll need some more advanced method. But if it's missing completely at random, usually use mean, median, or mode. Categorical, you usually need to use mode. Reason for that is, how do you get the average between a cat and a dog? That's not possible.
Yeah.
And you can't get the median. How do you sort cats and dogs? Which one is worse or better or lower or higher? That's not going to work. So you need to use the mode for categorical.
Yeah. And that's a good example of how you use normal distribution as well to understand better the data and also make the right decision which way that we should go for median, mode, or mean.
Exactly.
Yeah.
So like you were saying, if you look at the column, you plot it, you get the distribution, and in this lovely picture you can see, depending on the distribution, could be normally distributed, then the mode, median, and mean usually lie on top of each other, really similar. But if you look at left skewed, the mean is usually much lower because there are outliers on the left probably that are really small, dragging down your mean. Median means 50% of your data to the left of that value, 50% to the right. So it's just to show you, if you choose mean to fill all the gaps, your model will have a different outcome because these values are different. So you need to make sure to know what your distribution looks like to decide which of these values you'll be using.
Right. If we want to build a model from this data set and if we want to split and we want to avoid overfitting, so better to split the data set between 2. So for example, 80% for training and 20% for tests. So we will run our model with the training data set and validate what we are running into the test data set. So pretty much splitting into 2 with different amounts of data.
Exactly. And like Andre was saying, just to emphasize again, so you're sure you understand, you need to split this because you need to train your model on data and then test it on data it hasn't seen. You can't train your model and then test it on the same data. Your model was built on the data in the training set. So you need something it hasn't seen to see if your model is actually performing well. Because otherwise, like Andrew was saying, underfitting, overfitting, you need to make sure that what you're training there can be tested somewhere else with data it hasn't seen, and then you can use that to see if your model is actually doing well.
True.
So then, like we were saying, so just the steps to take. First step is the previous slide, you split your data. Andrew is saying 80% for training, 20% for test. That can differ. It can be 70-30, but we just used 80-20 for this example. Then next, you fill the gaps. So either with mean, median, or mode. And then after that, you can train your model. For example, random forest model is what we're using in the second part of our demo, but any model you can use. So fill the gaps, train your model. Then now that you have this model that was trained, you need to use exactly the same model and run it on the test set. So now fitting that to the test set, you get your predicted values. So in the test set, you have the actual values. But now with the model, you've got the predicted values, and now you can compare these two. So if you've got actual and predicted, compare the two, and you can see how well your model is doing. And that's what we'll be looking at next. So remember, actual, predicted, that's all you need for the next part.
Yeah, once we already have our model and we have the output of this model, we got to validate if these numbers, if these results are reliable.
Yeah.
So a way of doing that, so that using some statistical methods such as mean square error, mean absolute error, and mean absolute percentage error. That will be very important to validate which one that we will choose on that can be like a different model or a different approach for our data set.
Exactly. And we just chose these three. There are many others that you
Yeah.
can use. So depending on what's important in your model, you use different things to validate your model.
Okay.
But just for this demo, we're using these three. And then, like I said, to be able to look at the model to see how well it's performing, you need actual values, predicted values, and in this case, it's the weight of the cats. Some of them you can see it's correctly predicted, and others, they're not really predicted correctly. And then using these values, we go to the formula.
Yeah, all these formula that may look very complicated, but actually they are part of lots of libraries. That's good for understanding what's happening underneath this code that we are running, but actually it's all in the library, so that's good to know how that works underneath. So they are validating and calculating all these errors between the actual value and the predicted value. So
exactly, like you were saying, it's nice for those that want to know. This is the formula. For those that don't care, it's fine. They are Python packages that you can just feed your data into and get the results.
Yeah, it's even available in Excel as well. So
yeah,
that's
true.
worth. Yeah.
Then lastly, you need to be able to compare the models with something. You can't just say you get the mean squared error, okay, this is doing well. You need to compare different models and then see if it's actually performing well. So we took three approaches. Firstly is just filling all the gaps with mean. Then we filled all the gaps with median. And lastly, we filled all the gaps with mode. So we've got three different models or three different approaches to compare. And then all you have to do is you take the mean absolute error of these three methods. So we've got the filling just with mean, filling just with median, and filling with mode. Looking at mean absolute error, it looks like the mode is performing best. To remember, in this case, for mean absolute error, mean squared error, and mean absolute percentage error, you want the lowest values. So in this case, lowest value is doing well. So for all three, it looks like the mode was performing well. So according to mean absolute error, mean squared error, and mean absolute percentage error, all of them say that the mode method is the best. So that's nice to know. So you can see it makes a difference. Your model is actually performing way better with the mode than with some of the others.
Yeah, so, and just make that clear, that is the result for this exactly data set that may differ from different data sets. So
yes, exactly.
That's also always good to take all these steps to make sure that we are going on to compare the right way.
Yeah, exactly. Same data set and also same model. I mean, same. So random forest model was used to fit the model. So random forest for all three of them. So that stayed the same. The data set stayed the same. All that changed is how you fill the gaps. So it shows you that how you fill the gap really makes a difference in your model. Then that was all regression. So you can either have regression, it means you've got numbers that you're trying to predict, or you can have classification. So that could be the cat is sick or the cat is healthy, male, female, anything that's categorical, that's data classification. So there are just a few terms that you need to know: true positive, true negative, false positive, and false negative. So true positive, if we're looking at trying to predict if a cat is sick or not sick. So positive is being sick. So sick animal correctly identified as sick, that's true positive. So false positive, that means the healthy animal was identified as sick. Then true negative means healthy was identified as healthy. False negative is sick is incorrectly identified as healthy. So you can already start thinking some of these could be more important in different situations than others. So depending on that, you'll have to look at the next slide, which is what we want to look at. So different situations for different methods.
Yeah, after having all these results, we can have different approaches, like we can have precision, recall, and accuracy. So we use this matrix to see the predicted values and the actual values and compare them if we have more precision, if we are having lots of true positives, and or even if you are having maybe false negatives. So depending on situation, depending on the data set, depending on the result that we need, we will go for more precision or more recall, for example. So as we were saying, when that comes with something related to health, so we don't want to be called as sick when we are not. So better having a better precision. And for example, for computer virus, that much better saying that this is a virus and checking then again and saying, all right, so it's not. So depending on the data set and situation, we go for one another.
Exactly, with the virus, rather false positive and checking than saying, oh, it might not be, and then it was actually.
Yeah.
So a very good example. So precision, recall, accuracy, there you can calculate it with the formula. And in this case, precision, recall, accuracy, you want that value as high as possible. So for regression, those ones we looked at lowest possible, these ones higher the better. So like I was saying, higher the better. We did exactly the same as we did previously. We filled for the first model just everything with mean, second one just with median, lastly just with mode. And like I said, highest, better. So mean for accuracy was the highest. The mean for recall for all three methods were highest, and mean for precision was also highest, which means we should probably be filling these gaps with mean. It probably won't always be mean for all three the best, but in this case we're lucky. But you'll have to then decide what's important for you. Then I'm not going into all of these ones, but these are methods that you could be using. That's predictive and statistical methods to fill the gaps. We are not looking at them like I was saying, but please have a look at them if you're interested. They are actually really interesting to look at.
Nice. Let's jump into time series data set. So time series data is simply observations over time. So if we have lots of cats and then we want to take the observation that we got from Saturday, Sunday, and then we go day after day having all these numbers, and then we have data over time. So that's all about time series. So there are three main ways of filling the gaps when we have time series data set. There are forward fill, backward fill, and interpolate fill, which we'll cover. Taking again our roadmap, so we are already identified if it's missing data or not. We have many different categories of missing data. Going for time series, we have these three main categories, three main techniques to fill the gaps. And also we have deep learning approach, which is not we will not cover tonight, but it's also very important. But it's nowadays much more so for study, so that's not so shared in some libraries that we are working with, or maybe Excel. So that's we will keep it for later, but we will cover these three: forward, backward, and interpolate fill.
Yeah.
For forward fill, what we have is for observation that we have. The last observation field, we will fill all the others with the same number. So for example, for 1st January, we will go for number 4 for the next 2 days since they were empty. So we will fill in with the forwards with the last observation. For number 7 as well, for backward fill, what we will do is taking the last observation and fill in backwards. So let's say we have number 7 here, and then we will fill 2nd and 3rd of January with number 7 again. And then we go for the last one,
Yeah,
interpolate fill.
Yeah, luckily forward fill and back fill is quite easy to understand.
Easy,
And then
yeah.
interpolate fill is also not that difficult to understand. You've got missing data on the 2nd and the 3rd of January. You'll see the 1st is the number 4. The 4th of January is number 7. Now with interpolate fill, it tries to smooth out the curve. So you'll see for 2nd and 3rd, it fills it with 5 and 6. So then it has a nice smoother curve going from the 1st to the 4th. And then also you'll see that the 5th and 6th is missing again. So it will try to fall between 7 and 9, 7.7 and 8.4, you'll see is the value. So once again, it tries to smooth out the curve. So it's not the jumps like in forward fill and back fill.
And how we compare, we do pretty much the same way as we do on the other data sets. Is pretty much using the same statistical methods to compare what are the results for each of them. So we will use the same methods that we were using previously on the other data sets for time series as well.
Exactly. So like you're saying, there will be something that you want to predict. You'll split it. You'll get the actual values, predicted values, get the mean squared error, mean absolute error, and mean absolute percentage error, compare and see what works the best. So now that we've covered everything, let's quickly go through the roadmap again. So we've done the whys. Then we identify the reasons for missing data. So we'll be looking at the missing completely at random, missing at random, and missing not at random. Then after that, we looked at either you can fill the gaps or delete the records. Then remember, we've got time series and non-time series. So firstly, looking at the top non-time series, fill with the mean, median, or mode. That's for missing completely at random. Then if you've got some missing at random or missing not at random, you'll probably need to go for some more advanced statistical method. And then Andre was doing time series.
And then if you are working with time series, then we can use these 3 main techniques that we are using here, which are pretty straightforward. So forward fill, backward fill, and interpolate fill. That makes this last one smoother transition from gaps in our data set.
Exactly. And that's the end of part 1. So hopefully you guys know all the theoretical knowledge by now. I know it was a lot, but in the second part, we'll be going through the whole roadmap again. And then we'll be doing the practical application. So hopefully we can answer some questions that came up that they had just by going through it again and just working through all the theory, but now applying it practically.
Yeah, that's going to be nice. So application of identifying and filling in missing values. So let's jump into.
Yep.
So
starting again at the beginning.
Starting again our roadmap. So saying the whys.
Well, the whys is really applicable for this one. So the data set is actually a heart disease data set. So why do you want to fill the missing gaps? Well, you want to be able to predict as well as possible whether or not someone has a heart disease or not. So it's really important to know that there is missing data and you're actually filling it as good as possible to have a very good, accurate model.
Yeah, that's an open data set, and that's something that happens all the time when we are working with data. So we are having data sets from different places, different hospitals. So that comes with lots of values that comes in one data set and another doesn't. So that's good to see all the difference. And also, anyways, we got to have some results. We got to work with this data, even if we are having these missing data. So that's a good example of how data changes, and also we always have these gaps in our data sets.
Yeah, so specifically this one, you said it's an open data set. It's on that website where you can see. Then they were for 4 different places: Switzerland, Cleveland, Hungary, and VA Long Island. We only have half an hour or so to cover the practical part, so we'll be looking just at Hungary. And then it's a categorical data set. And the column that you want to predict or that's of interest is num. The num is, if you look at that, it says less than 50% diameter narrowing. That means you don't have a heart disease, and greater than 50%. So it will be a 0 or 1. So the value will be 0, means no heart disease. 1 equals heart disease. So we'll just be trying to categorize either 0 or 1. Then these are the columns of interest. There are quite a few more columns, but they indicated on the website as well that these are the 14 columns that you should use when trying to build your model. As you can see, age, that's a numerical column. 6 is 1, 0, that's categorical. Next one is also just 4 types categorical. So if you look at those columns, there are quite a few categorical variables and then just a few numerical ones. And if you remember categorical, if they're missing, you'll just fill with mode. But for numerical, you want to dig a bit further into that. But before digging into that, let's just see, is there actually missing data? So that's the first question. Identify reasons for missing data, or just firstly identifying whether it's missing, then we'll be looking at the reasons. So this is the data set. So it's called process.hungary.data.
Yeah, so we are loading data set here, and then that way we can have a look and identify if there is missing data or not. Just at first sight, we see that it's missing data because we've got lots of columns with question mark here. So that's even more clear than the other that we were seeing. So we've got lots of missing data here, but of course we can use some data visualization ways of having a look at this.
Yeah. But like you say, this is very clear. It's missing.
Yeah.
So like you were saying, question marks equals missing data. You just filled all those question marks with a nan, and that is identified as missing values by a lot of the functions that we'll be using in Python. So you just do a dot replace question mark with nan, which is easy enough. So there you can see in the data set, it now has nan values.
And then we go for using identify if there is missing data, if there is empty values here. So that goes for all the columns and then says false or true if there is missing data in each column.
Yeah, and it looks like there are quite a few columns with missing data, which is good for our example.
Quite works low to work, yeah.
And then it's also good just to see the percentage of missing data. So in this case, you can see the CA column actually has 99% of missing values. That's not great. Not much you can do with that column.
Yeah.
And then even the thal column has 90.5% missing. And then you'll see at the bottom, the last 4 columns only has 1 missing value each. So that's not too bad. So next, we want to see what's the reason for missing. Is it missing completely at random, missing at random, or missing not at random? Firstly, another way to visualize it is just by using this nice function msno.bar from the missing no library. Very useful. You just give your data set, it displays this. It's awesome.
Yeah, that's how it is. We just imported this library, and then we use our data set with this bar. So that's how it is. There is no any other line of code that you need to use for having this visualization.
Exactly. Awesome. And this is a really good first view, just seeing there's your missing data. And you can see the CA column. Remember, it said 99% missing. It says there only has 3 values that's filled. So we'll probably be dropping that column. It doesn't have anything useful in there. I mean, if you fill it, it will be filling 99% of your data with a value. It's not the best idea.
Yeah.
Then we want to look at the positions of the missing data. Once again, just msno.matrix this time, and giving it your data set. And they remember white bar, that means it's a missing value. Black means it's filled. And now we want to try and see if there may be a correlation between these missing values. Next, we'll need to sort it. So you just sort your data, and once again, give it to the msno.matrix function. And we sort it on the value slope. It doesn't seem like the other columns are actually correlated. And I think we'll probably need more domain knowledge on the heart disease to be able to dig into the data. But for now, just for our experiment, we're going to assume that this is missing completely at random, and then try to fill this with maybe a mean, median, or mode. hopefully in the future, if you want to play around with this more, you can add some statistical method. But what we want to show is just that it could make a difference just to dig into what method you should be using, mean, median, or mode, and that even that could make a difference. So looking at non-time series, and now we want to look at what do you fill it with. So we want to identify the column types because, like you know, Andre, that we want to either fill it with mean, median, or mode, but categorical can't use mean or median. So need to identify, you can see that mostly categorical, the col column, col column and trest BPS and thallic, those three are numerical. For the rest, unfortunately boring, you'll need to fill it with mode, there's no other option.
Yeah.
So like I said, 3 columns.
At least very important to identify if there is categorical or not, because if we fill understanding as numerical, some categorical column, that will be a problem at the end. So
exactly,
that's good to understand each of these, if numerical or categorical at the first beginning.
And also, like you're saying, that's really important because some of the columns actually had a value 4, 7, and something that's actually categorical, but it could be seen as numerical by your function. And you can actually add the mean and use the mean, but that's incorrect. It's not gonna make your model good because you're interpreting the data wrong. So you're suddenly gonna get extra categories in that column where it's not correct.
Yeah.
So like you're saying, it's important to know what's the column.
Yeah, exactly. If we have some data set like we were saying cats and dogs, that's easier to understand. Each is categorical or not. But since we have some complicated and something that is not our domain knowledge, so that's good to understand.
Exactly. So now looking at this, we're plotting the distribution of the 3 numerical columns. So you use the nice Seaborn package and then plot firstly the col column. So looking at this, it looks like it's skewed to the right. So skewed to the right means the tail goes flat to the right-hand side. Then trest BPS could also be slightly right skewed. And then thallic looks more normally skewed. So it's good to know that because if it's skewed, it means your mean, median, and mode are not on top of each other, which is nicely explained in the next slide. Just to show again, if you've got a skewed column, so in this case, it's right skewed. So looking at the right, it means your mean will probably be more to the right, so a higher value than your mode and your median. So it's just good to know if you're filling the gaps, there is a difference between the mean, median, and mode, and that could influence your model, or probably will. We'll be seeing that later.
All right. So since we already understood which columns is each, we already know which one is categorical and numerical, and also how to work with each of these ones. So we go for column by column, saying, so for example, the first one, which has 99% of missing values, dropping, that will be one way of work with that. So dropping the second one, the others categoricals filling with mode, and for numerical we will try each of these approaches, like filling with median, mean, and mode.
Yeah, exactly. So now that we know the options that you can take, we want to see what it can do. So we'll be splitting it into the training and the test set. Here you can see we use the sklearn.model, and you import the train test split. That makes your life easy. You just give it the data set and it will do the split for you. So we split 80%, 20%, and then you'll see there at the bottom, you end up with the training set, the test set. Now it's the X test and the X train because we're splitting Y train, Y test. Y is the value which is num. So num column was if you've got a heart disease or not, the 0 and the 1. So we're just splitting it into all the columns that you use to train your model, and then the Y is just your output that you want. So
for the first model, we are dropping the one column, we are filling with mode, and filling numerical columns with median. So
we went the easy route, just saying all categorical mode. Obviously that will stay the same, but then all numerical for now, just with median. And then you can see in there, I just made a nice paste of, you can see the data set doesn't have any more missing values in there. So first you train the model, you'll see we use the random forest classifier, and we keep the n estimators 10 and the random state 0 for all of them. So every time we train the model, that will stay exactly the same. All that's changing is how you fill those gaps. So we want to keep that constant so that when you actually compare it, it's a valid comparison.
Yeah, so we are not comparing actually the model itself. We are not comparing random forests against different other models.
Yes.
We are comparing how we are feeling these data sets and seeing how that changes between them.
Exactly, and
That's-
showing that it makes a big difference how you fill the data. And then you'll just see we use model.predict on your test set. So you want to predict the num column for your test set because you trained on your training set, and that model or that data wasn't, the model hasn't seen the test data set yet. So it's completely independent, doesn't know what's going on there. So you can see if it's actually a good fit or not. And just to reiterate, we're looking at classification model. So we'll be looking at precision, recall, and accuracy. So I'll just leave that for a few seconds if people want to just get their heads together again. Cool. So going further, we are using these libraries. So just sklearn metrics. So you'll see this accuracy score, precision score, and recall score. So like we were saying in the talk, you don't need to know the formulas. All you need to give is the actual values and the predicted values. And there you can see y predict and y valid. So that's just your y valid is the test data set that you had the actual values, and the predictions is what you got that was predicted. So then you get the accuracy, precision, and recall with this nice formula and function where you don't actually have to calculate anything yourself. Just feed it the data, it will give the value back. So first model is we dropped the CA column, which had 99% missing values because that's not a useful column. Then you fill the categorical columns with mode, like we said, and the numerical columns with median. There you see accuracy is 77.9%, recall, same, and precision 80.17. That doesn't tell you much. It says, well, that's what it is for that model, but you need something to compare it to see if this is actually the best model you can get.
Yeah, so let's see if maybe having a different approach so that we will cover on the model 2 that we are dropping the same column, again, dropping one other column that we had only 90%. We had 90% of missing values.
Yeah.
So if that was important, maybe the model 1 would be better than model 2.
Yeah.
So we are dropping these two columns, filling categorical columns with mode the same way that we did before.
Yeah.
But now we are filling numerical columns with median. So
Yeah.
the result was for model 2, accuracy it was 83%, recall the same, and precision 84%. So even that we drop one other column, we are having better results then.
Yeah, which is really interesting. But if you
Yeah.
think about it, 90% missing, you're assuming everything would just be the mode value, which is probably not true. So it's better to actually just drop that column than filling in the missing values for that column, which is really good to know. Then third model. Now we keep the CA and the thal column dropped because we saw also dropping the thal column, that's a good choice. So we're going to keep that one dropped and see if we can improve the model even further. So now we are filling the col column with mode, and the other two numerical we're keeping as median. And you'll probably not remember, but those two columns only had one value missing each. So I don't think the method of filling that is really going to make a difference. So I'm focusing on the col column. So now I'm changing that to mode. And you'll see it actually doesn't make a difference. So in model 3, it's the same as in model 2. Now I'm going to try something else. Maybe let's fill it with mean. And once again, no difference. So in this case, it doesn't make a difference because if we quickly look on the next slide, I made a quick summary. We dropped the CA column, 90%, 99% was missing. Model 2, we dropped the thal column, which had 90% missing. But then, like I said, model 2, 3, and 4 are doing the same in terms of accuracy, recall, and precision. But in the col column, only 7% of the data was missing. So that's not a lot of data that's missing. And I looked at the median, mode, and mean, and they were lying really close to each other. It was like 230, 240, and 250. And the graph actually goes from 0 to 700. So they're fairly similar, and it's only 7% missing. So I thought maybe let's dig a bit further and actually go and remove more data from the col column just to see and show you that it actually makes a difference, hopefully. We'll see in the next slide. So we randomly removed more data from the col column, and you can see in this graph that the col column has a lot more data missing than previously. now we're just going to do exactly what we did. We're going to run all 4 models again.
Right. So all these 4 models that we are running now with this new data set that we are taking from the last example, but with more missing values or less data.
Yeah.
I would say. So for the first model, what we are doing is remove the CA column, filling numerical columns with median, and then model 2, we are removing CA and tall column, filling numerical column with median. So for the next one, removing the same columns, filling 2 other columns with median, and filling call with mode. So for the last one would be removing 2 columns, filling more with median and also mean. So the result were we had this difference was very significant. So that's clear to see that from model to model, as we are having less data in our data set, we have more gaps. So we have better, we are having different results from that. So that changes very much more from model 1 to 2, and also we are seeing how filling these gaps changes the accuracy and the precision.
Exactly, and it's just one column. It's just the call column that we changed now with mean, median, and mode for the last 3 models, and you can see it really makes a difference. The last one, the precision is actually 89%. So although we manually removed randomly more data, it was just to show you that if you use the mean, median, or mode, it really makes a difference. You need to play around and see what's the best method to fill, and then that will improve your model. And just by filling the gaps correctly already improves your model before you even start fine-tuning the model. So then it could already improve even more. And probably if you use some statistical method, if this was not missing completely at random, filling the gaps maybe even more accurately could improve the model even more. So it's really important to fill those gaps correctly before you even start thinking about what the fine-tuning of the model could do.
Yeah, right.
So like I was saying, you can look into other more advanced methods to fill the gaps, but we just want to make sure you understand that taking that first step, looking at the missing data, it really makes a difference in just exploring the data, making sure that the data is good. Remember, garbage in, garbage out. If your data is not good, your output is not going to be good either. Then,
all right, let's talk about time series, and again talking about cats then.
So
all
let's take a lighter approach to end this talk.
Yeah, sure. So saying that again, so data observations over time. So we have our roadmap that is well known by this seeing if there is missing data or not, identifying the categories, filling those gaps, and if there is missing data, we have different approaches, different techniques to fill them. So firstly, we are identifying if we have missing values. So we in this data set we have 3 columns. So we have date, we have number of cats, and the amount of food by kilos that is used in for these cats. So we see that there are lots of missing values in the number of cats throughout the time that we are having this data set.
Yeah. And we also, just to point out, we want to fill the gaps for the number of cats, but the number of food is probably what you're tracking over time and what you want to try to predict maybe going forward.
Yeah.
So first, we're looking at how to fill the gaps for the number of cats.
Yeah, in order to have a better result for our predictions. So we will fill those, and then having the better understanding on the better modeling, I would say. Yeah. For fill, what we are doing here in our data set, we identify that we have some missing values. So for example, for this line 178, we have a missing value. So as we were saying previously, for the fill completes with the data that we had as for the last observation. So we had 45, and then we complete for the next day with 45, and pretty much as this, using that one library that goes very straightforward. We are using one data set and then filling with this technique that takes one line code.
Very easy. Then next is backward fill. So you'll see once again the same gap is missing. So line 178, because like we were emphasizing, you need to use the same data set and filling it so that you can have a good comparison. So line 178, that's missing. And now, because it's backward filling, you'll be taking the 28th of June 2020 and then filling the gap. So 32 would be used to fill the gap in 178.
Yeah. And then we go for the interpolate fill, which makes a smoother transaction from one observation to other. So taking the same example, same records that we were using. So rather than take the last or the next observation, that makes one number between those two.
Yeah, so you'll see it's now 38.5. And in this case, you just use interpolate function, which is really easy.
Yeah.
So now that we've got these three, those are the three methods you'll be using to filling. So you remember, we've got the column of missing data, which is the number of cats. You obviously need a date column, it's time series. So the date column is date. Then the column to predict, or the column of interest, is the weight of the cat food per day. So for time series, you need to remember, if you're splitting the data 80-20, you need to use the first 80% of your data. It's over time. You can't randomly choose dates to fill it. You need to make sure first 80% is used to train the model, because you need to predict going forward the last 20%. So split 80%, fill the gaps. Remember, you said forward fill, back fill, and interpolate fill. So we've got those three models. Then you'll get the actual values and the predicted values of those last 20%. And now you need to compare once again the actual values and the predicted values. Same method as non-time series: mean squared error, mean absolute error, mean percentage, or mean absolute percentage error. And then if you compare those ones, you can see, because we've used the same data set and the same training and test set, everything stays the same, and you'll be using the same model in each one. And that way you see what's doing well. So just to reiterate, Andre can take you through it again.
All right, so we are pretty much reiterate so what we did in our last example. So that pretty much the same way that we would do for time series, but we need to consider that time series have this classification. So we need to consider that there is a link between the time. So let's, for example, once we have this data set, we fit model to train the data, predict the values that we are having, those compare the actual value to the prediction. So with these statistical methods, we can check if there is, how fine is this, comparing what the way that we are doing, how we were doing previously, removing one column, adding one column, filling with different techniques. So
Exactly.
in time series, so we would compare with three methods. So let's say that we fill with forward, backwards, and interpolate fill, and then we compare using these statistical methods, and then we check these different approaches, see the number for each of those, comparing, and then taking the best model to use and the best approach.
Exactly. So the steps are the same, like you're saying. So if you understand the steps, it's easy to apply. So once again, just taking you through the whole roadmap. We've got missing data or not. So you need to identify whether or not you do have missing data or not. If you have it, identify the reasons. Reasons: missing completely at random, missing at random, and missing not at random. Then either fill the gaps or delete the records. If it's non-time series, remember, if it's missing completely at random, easy enough to use mean, median, or mode. If it's missing at random and missing not at random, rather probably go for some statistical or some advanced method. And then lastly,
for time series, we have our 4 techniques that we are mentioning here. The ones that we showed on the practical part is forward fill, backward fill, and interpolate fill.
yeah,
And a
or
deep learning approach. Deep learning approach is something that there are some very cool papers on the internet saying about deep learning approach. So that's probably something that will be available in the next libraries in Python. Yeah, probably.
So hopefully by now you realize that even just the smallest change or just the smallest investigation into your data to realize the reason why it's missing, and then filling with the correct things, making sure is it categorical, is it numerical, and then looking at the distribution scores, it really does make a difference whether or not you use mean, median, or mode. So just make sure in the future that you just spend a little bit of time digging into your data and making sure that you actually follow the best approach.
Yeah, and the key word for all for this as well is the quality of the data that we are using. Sometimes we don't have the quality of the data that we need because we are having data from different parts, different sectors, and maybe even sensor that is not working all the time. So having this approach and taking these steps, we can ensure more quality in our data sets, and that this quality will get a different result in our insights, in our models, in our work.
Exactly.
Yeah, great. That was really interesting topic, guys. Well done. There are some questions in the chat, and I actually have a few of my own, but let's read the ones in the chat. If there's anyone who has more questions, put them in the chat now, and now's your chance. So Kaylee or Callie asks, in your daily life, in your job, which technique do you use the most to fill the missing values? The mean, median, mode, or some other data science model?
Well, can I say for time series, I would go for interpolate fill. That makes a smoother transaction. So from the examples that I used to work, I saw that the accuracy is better for interpolate fill. But even though I try to check between those three techniques and then see which one that I choose. So for my understanding, I would go for interpolate fill.
And have you worked with non-time series much?
For non-time series, not that much then.
Yeah. In my case, the reason I dug into this is because, like I was saying, my colleagues, we were working with just mostly filling with mean. And as I was digging further, so I need to look into the future then to see, now that I've done all this investigation, what I will be doing next. So I can't, unfortunately, give the best example of saying what I use the most, which is why we were digging into this. So in going forward in the future, definitely I'll be looking to that more.
Okay, so Pierre asks, how do you prevent inherent bias in limited data from being exaggerated by interpolating your own chosen data into missing data? And is that the sensitivity method that you were mentioning?
I think the good way of measuring that, and I would say that all these statistical methods that we are taking, that's a way to avoid these trends that we can make if we are filling those gaps. So a good way of not going against our data is taking this control of statistical methods and measure, I would say.
Okay. Do you want to add to that, Francis? Or?
Yeah, I'm just thinking to prevent bias, but if you've got limited data, it always makes it different. It's easier to have a big data set and then splitting it. But when it's smaller, that gets more tricky because just taking 80-20% split, you might have too little data to go forward. So that really does make it difficult. Yeah.
All right. So Rodrigo asks, is there a way to check if missing data is at random or not?
So if it's at random, well, easiest approach, well, not easiest. First approach is, like we were saying, just plotting the data, seeing it visually. But then there are other methods like the t-test and the chi-square test where it's seeing there, it's easier to see if it's missing at random. So seeing whether the columns are dependent on each other or not. That will be, it's good to do both approaches. I think just using visualizations or just using the numbers is not the best approach. You need to do both. If you do both, that's an easier way to see whether it's random or not.
Yeah, I would say that as well. Like visualization, I think that's the most important part. Most of data sets, we can have a very good insights just from the visualization. But if it is not enough, or even the data set is very complicated, as we were working with these heart disease, so better taking these 2 steps.
All right. Pierre asks again, and don't think it's a question, but he says that the mean could be time-bounded, a moving mean, so filling in any specific average could be pointless instead of normal interpolate that is linear.
Yeah.
Don't think it's a question, but
yeah, but that's also true. I mean, if you've got time series and you go over time, like you were saying, you can't just take the mean over all time. That's really not going to be your best approach. So, like you were saying, taking the moving average, that's way more accurate. Yeah.
All right. I think so far that's it for the questions in the chat, but I have a few of my own, if that's okay. So one thing I wanted to ask is, at what point do you consider dropping a column? So if you dropped the column earlier that had 99% missing data, so what's the threshold? How do you make that decision?
Yeah, so that's a difficult question. Some people might say above 90%, others might say 80%. That also depends on your data. It depends if it's a really important column for your model or not. But in our case, it only had 3 values, which was 1% that was filled. If you fill that column with the mode, assuming that all the rest of the data will have that column, that's not your best approach. So you also need to drop it and see if your model actually improves or not.
Yeah, I would say that using the same model for different approaches, that will answer this question. So if we have one column that we are not that sure if we should drop or not, it's much better using the same model and then dropping in one situation and the other we keep in that. So I think that's the safest way to do that. So
All right. Another question I had is when you're talking about mean, absolute error, and the 2 other ones, right? Mean, absolute percentage error.
Yeah.
Is there ever a scenario where you might prefer one over the others of those, or they always you want them to be the lowest, isn't it?
So there are different things that modelists will be looking at. So you won't always just be looking at those 3, there are others. So it depends on what that actually means to you and what's important for your model that you'll be looking at different approaches. So no, you can't go for one fits all when you need to see what's important for you.
Got you. One other question I had is the difference between precision, recall, and accuracy. I wonder if you could describe that. It's a measure of measuring the accuracy of your model, right?
So can we go back to that slide?
I just wanted to know what the difference is exactly between them.
Yeah, I think so. Precision, that the same as we were saying for the example of heart disease, we don't want to say that this prediction has false positive. We don't want to say that someone have got some heart disease if they don't. So precision works much better for not having false positives. So if is there not a problem in the model, then we can go for recall. So that the same way that we were saying. So for example, if you are trying to see some computer viruses or some fraud in the system, so it's not that issue to have false negatives. So recall and precision, that differs between how we're gonna get the result that we need.
Okay.
And then accuracy takes everything into account. So it's taking all true positives, true negatives, and all of these blocks into account.
Yeah, it's the balance between them.
Okay. And when you're talking about time series data, you mentioned forward fill, backward fill, and interpolate fill. So is there, between forward fill and backward fill, is there a difference between those in terms of, like, when would you choose one over the other?
Yeah, there's no right answer to that. So I think from some observations, from some experience, we might go for one way or no other. But I would say that checking those 3 ones and doing those validations and checking by the numbers would be the best approach.
Okay, so you try one and measure the accuracy, right?
That's it.
Okay,
Yeah.
Gotcha. One other thing is, do you have any examples of bad ways to deal with missing data that you might encounter in your daily work? Like, is there any examples of the wrong ways to deal with missing data?
Well, I think one wrong way is not digging into why it's missing and maybe just removing all missing data.
Yeah.
Then if it's actually missing not at random or missing at random, removing that will remove maybe a section of the population, which means you're just then building it on some people and excluding others, which will not give a true reflection of the population.
Yeah, I would say that just taking one rule for all missing data that we have in different data sets, I think that's the worst problem. So if we drop all the columns that we see missing values, or just filling with any values that we need, so both ways are wrong approaches to work with missing values.
Or just filling with mean and not seeing if it's categorical, even though categorical could be 0 1s, then you get halfway in between, and that's not a true category. Even though that could, in some ways, if you fit the model, it could maybe improve the model by filling with mean, but it's not correct. It's inaccurate. So that's also really bad. If you fit the model, you see, oh, it improves by using mean, but you're not seeing it's categorical. Yeah. That's a really bad approach.
Yeah.
Tony asks, how do you know if you have enough data left after the cleanup for future processing, like building models?
I think you'll need to look at the percentage of missing data. you'll obviously not be removing 80% of your data. And also specifically, you need to look at the reason. If it's missing completely at random and it's a small fraction, that's fine. But if it's not missing, if it's missing at random or missing not at random, you can't usually just remove the data.
Yeah, sorry.
Yeah, no, go for it.
Yeah, we try to avoid at maximum to delete the data. So every data worth it. So if we are having a data set, it's much better to keep the data there. But as we saw here, there are some columns that have lots of missing values. So doesn't change our model, doesn't change the results from that. So that's why we sometimes we drop it. But that's the less way that we try actually.
Right.
We try to always keep the value as much as possible.
Like you're saying, fit the model, and if you keep on dropping, keeps on worsening the model, it's usually an indication that's not a good idea to keep on.
Yeah, and is there, I guess related to this question, is there a minimum amount of data you need in order to train a model?
Don't think so, because you get small data sets and large data sets. I don't think there's a good way to tell you need at least this much data. There are different modeling techniques that fit smaller data sets and larger data sets. So I think then rather start digging into which models would fit your small or large data sets.
Okay, we have another question from the chat. So is there a drive for model explainability within data science in your experience? He agreed that visibility, like when you are building your models, are important. So checking MSE, cardinality, etc. So the question was, again, is there a drive for model explainability within data science in your experience?
Not mine much. Yours?
Yeah, not very much.
Okay.
That's a bad answer, sorry.
No worries. I think that's it for. I have actually one last question. So you were talking. You had you used a bunch of different Python packages in your presentation. So I wonder if you could just quickly go over those, what you use them for quickly. So I saw that you were using pandas. You're using this missing NO library.
Yeah, missing NO. That's for all the visualizations.
Right.
sklearn was from there. You can get the MSE and accuracy and recall and all those packages. What was your time series package?
This time series package that we were using.
And you're also using Jupyter Notebooks for
we actually used Colab notebooks because as we were working on this talk, we wanted to be able to work together on the same notebooks, which is actually really nice for collaborating with your colleagues if you want to.
Yeah.
Yeah.
All right. So I think that's it for the questions. So now we need to get back to the best part, the hoodie giveaway. So I think we're going to display a QR code on the screen where you can go and answer the question about today's topic. So if you go there, follow the link, fill out the form, you have a chance to win one of these Capgemini Build community hoodies. So I'd like to thank you both very much, Francis Dreyer and Andrew Marquez. And I also want to thank you for watching Capgemini Build Tech Talks. And see you next time.
Thanks so much.
Thank you. Thank you.
Yes.